Hello guys, this is Happymath channel, and in this video we continue with the trigonometry integration. This is the part 3 of the anti-derivation video. So if you don't watch the previous video, so please see the part 2 and part 1 first. And in more specific, in this video I want to share you how to take the integration of the trigonometry function. And let's start with the basic method of the trigonometry integration. First one, I have the you have learned about the derivative of the sine x function. D of sine x function will become to the cos x times with dx, and the main function from the inside the derivative will come when we move out of the derivative and become the cosine. As you can see this in the left in the side in the right side of the derivative will become to the left side of the derivative. Yeah, and when you take the integration of the cos x, it means you have to move the main function cos x from the outside of the derivative becomes the inside of the derivative, and the main function will change, and it change become sine x, for example, like this, and cos x becomes the sine x. Okay, so when you take the plus or minus or take any constant number with the cos x with the sine x, so derivative of the constant number will be equal to 0. So that's why the derivative of the sine x plus c is a stand for constant number, will become to the cos x times with dx. And of course, when you take again the invisible ways of the derivative is the integration. It means cos x of time with dx become from the outside the derivative becomes the inside the derivative. It have to become to the d of sine x plus c. It's quite easy to understand, yes. And just remember the main methods, main formula of the trigonometry integration like this. So maybe you will solve totally 100% of the own trigonometry integration exercise. Okay. Let's start with some basic exercise. First one, you have to take the integrate of the cos x times with dx. From the outside derivative, I want to move cos x, the main function, become to the inside of derivative first, and it become to the d of sine x. And when you take that, the side of the integrating and the side of the derivative will stand nearby together. So when they stand nearby together, it will become invisible. It will become invisible. So the result of this operation is become to the sine x plus c. You have to take plus c at the end of the integration because when you take the derivative of the constant number is equal to 0. So you don't know exactly what is the main function. When you take derivative, it becomes the cos x times with dx. So you have to plus c for own function when you take integrating. Okay, now continue with the second exercise. You have to take the integrating of the cos 2x times with dx. Now move back to the main function or the main method of the trigonometry integration. You can see this. The number of this position have to become or the same with the number of the z function. So after that, you got d of the sine x, and it means the main position, the position of the three position in here have to be the same. 1, 2, and 3 have to become the same, or it have to be exactly the same. So in this function, you see that the main function is not cos x, it is cos 2x. So I have to change from the dx here, it have to change become to the d of 2x. It means you have to times 2 with the integration. It will be x of 2 d of the 2x So it means you have to time with 2 of the dx. So for unchanging this main the main function, you have to divide by 2. It means you time with 1/2 for all operation. Okay, so from after time with the 1/2 ratio, the main function is unchanged, but but you can see that you got the main operation, the main purpose of the operation in here. You change of cos 2x be equal to the d of 2x. So apply the main method you see in the previous slide. You can saw that integration of derivative sine 2x here. So they stand near together. It means they invisible. And you take plus c at the end of the operation, of the integrating operation. Okay, it is the same. So the main function, the key point here is the cos of function d of that function and the sine of that function. It has to be the same. For example, when you take cos of x squared times with dx squared, and it becomes the derivative of the sine of x squared function. Okay, go on. In this function, you have to change dx become to the d of phi x. It means you have to time phi, and at the same time you have to divide by phi. Sine of phi x, and you plus c at the end of the integrating operation. Okay, very easy. In the same way, you will got the result of the z function is plus c. Okay, very easy to understand. And how about this one? And this one, the function of the cos x is 3x plus 2. It means you have to change from the dx, it have to become to the 3x plus 2. First, I have to change from dx become to the d of 3x. You time with 3 and you divide 3 at the same time. D of 3x. And maybe you can, maybe you remember when you take plus c, it means plus of the constant number. When you take derivative of the constant number, you can got the 0. So it doesn't matter if you plus 3 or plus 2 in this position. And now you can see that this position equal to this position totally. So you can change from the cos 3x plus 2 become to the inside of derivative. It means it becomes the d of the sine 3x plus 2. Sine 3x plus 2 is mean the sine 3x plus 2 is the original function of this derivative. And of course, don't forget plus constant number at the end of the integrating function, integrating operation. Okay. In the second one, first one I have to change dx become to the d of minus 5. D of minus 5x, it means you have to divide by minus 1 over 5. Cos 4 minus 5x, d of minus 5x. And it like 4, so I have to plot 4 more. 4 minus 5x. Okay, they are the same. So the original function of this function is n plus c. Easy. And we continue with this function. This may be more complicated, but believe me, it's not too complicated. You got that the main function of the cos x here is x power to 2. So you need to change dx become to d of x square x power to 2. So you saw that the 2x is here. So change the position. You will see that 2x times with dx near stand near together. So when you remember the power rule of the derivative, when you take 2x from outside, the derivative becomes the inside of the derivative. You should apply this method. Divide by and plus 1. So plus c. Okay. So from this one, I take integrate of the 2x first, and when you take that, you can have the result of d of x power to 2 in this one. Okay, so the main function of the cos x equals exactly of the variable of the derivative function, and after that we got the main function after integrating is a sine of x squared. So plus c at the end of the integrating operation. Okay, very easy. In the same way, with this function, I will move this bracket from outside of the derivative become to the inside of the derivative first. So first I have to change the position of those. And now I take the integrating of this one first. When I take the integrating of this one, 3 of x squared minus 2x, it will become to the d of 3 x power to 3 minus x squared. So the main function of the cos x equal to the variable of the derivative. So take cos function inside the derivative, it will become the sine function. The sine function is let's see. So after all, you can recognize you have to change from dx become to the d of the another function. So after that operation, you have to take the same function of the cos x become to the same function with the d of that function. So after that, you can take the trigonometry integration and you got the results very easily. Okay, another trigonometry integration is sin x dx. Come back to the original function when you take the derivative of the cos x plus c or only cos x. You will take the minus sin x times with dx. So when you move cos x inside the derivative become to the outside of the derivative, you have to change the main function from cos x becomes the minus sin x and times with dx. So when you take sin x from outside the derivative become to the inside of the derivative, the function will change to minus cos x. And when you take the minus cos x, you have to plus c at the end of the integrating operation. That's why I have the second main method for trigonometry integration in this one. Yes. So look at this. The position or the function of the sin x equal to the function of the derivative and equal to the function of the cosine in the result. Okay, three position here is have to the same. Let's start. Very easy with the first one. You just take the side x from outside become to the inside of the derivative, and it becomes to the cos minus cos x. And when you don't write the integration symbol or derivative symbol, you have to plus c at the end of the integrating function. Okay, and now 2 sine 2x times with dx. The 2 here is a scalar factor. It means you can move that number around of the integration. So I will move it stand nearby x. So dx becomes the d of 2x. The function of the side equal to the function of the derivative, so it is the same. So the apply the method, you will got that the original function of this function is minus cos of the 2x and plus c at the end. Very easy. Like cos integration, cos function integration. Okay. And maybe from now you can stop this video, watch my exercise, you do it by yourself, and after that you play video continuously, and you see the result. Okay. First one, I change dx becomes the d of 5, and you have to divide by 5. It means you times with 1 over 5. And x will become to the minus cos 5x plus c. Okay, this is the result. And the second one, sine, the main function here is 6 minus 2x. So first one I have to change dx becomes the d of the minus 2. Minus 2 is means you have to divide by minus 2. At the same time, it means you time the old integration with the 1 over minus 2. Six minus 2x and you plus 6 in the derivative function. They become the same. And the result of this operation is minus cos 6 minus 2x plus c. But in this one, you have one more step. This is minus 1 and this is minus cos. So minus times with minus 1 times with minus, it becomes a positive. And you got cos of the 6 minus 2x plus c. And this is the final result of the function. See? With this function, you saw that the main function of the sine is either x power 2 x squared. So I have to change dx becomes the x power to d of x squared. You find 2x outside of the derivative. So first one I have to move 2x inside of the derivative, and it becomes to d of x squared. D of x squared, so sine of x squared is as the method. The function of sine equal to the function of the derivative. So the result is minus cos of that function plus c, constant number. Okay, so that is the basic technique for integrating of the trigonometry. So from now you will take the advanced technique of the derivative of the integration trigonometry function. So you call that advanced technique, but you have to base on the basic method of the trigonometry integration methods. And this one, you got that the two main functions here, sine power to 4x and cos x. So maybe one of them have to become the main function of the derivative. For example, I want to move cos x from outside become to the inside of the derivative, so they will become d of the sine. The main function here is sine power to 4x, and the function here is sine of dx. So maybe this function like x power to 4 times with dx, and this is the power rule. So the result is x power to 5 divided by 5 plus c. And in the same method, the same formula, you will solve that. This will become to the sine power to 5x divided by 5 and plus c. Because the main function of this position equal to the main function of this position. Okay, we continue. The more complicated function in this function is the square root of the cos x, so I can't move square root of the cos x outside of the derivative, become to the inside of the derivative. So I will choose the side first. I will move side become inside of the derivative first, so they will become to the cos of it become to the minus of cos x divided by square root of the cos x. So minus of 1 over square root cos x is mean cos x power to minus 1 over 2 times with d cos x, and maybe you forgot minus sign, so I take the minus outside of the integration. This means cos minus 1 over 2 times with d of cos x. So look at this method. From this one, you will see that this is the power rule integration, and the function here is cos x. Cos x power to minus 1 over 2 d of cos x. So the final result is will be cos x power to minus 1 over 2 plus 1 divided by minus 1 over 2 plus 1, and it will become to the minus cos x power to 1 over 2 divided by 1 over 2. Sorry, I don't have the space for writing more, so I will write down in here. Divide by 1 over 2 is mean you times with 2. So power, the number power is 1 over 2 is mean you have to take square root of the cos x, and the final result is minus 2 square root cos x. Let's see. Okay, understand? And how about tan x times with dx? Tan x times with dx, so I will separate tan x become to the sin x divided by cos x times with dx. And that's like the previous exercise. I will move sin x become to inside the derivative first, so it will become to the minus d cos x divided by cos x. So minus of the integration d cos x divided by cos x. So you have to remember this formula. Integration of the dA divided by a, it becomes the length of absolute value a plus c. So a function is in this specific case is cos x. So the final result of this one is length absolute value cos x plus c. Okay. This is quite easy for you. This function is very complicated, and this function is very easy to take the integration. So I remove cos x from out, become to in a derivative first. Sine square root of sine x, it means sine x power to 1 over 2, and cos x dx is mean d of sine x. So from this one, this is the power rule integration. A power to 1 over 2 dA. This means a 1 over 2 plus 1 divided by 1 over 2 plus 1 and plus c at the end. Okay, so in the same method, we will got that sine power to 1 over 2 plus 1 and over the same number plus c. 1 over 2 plus 1 equal to 3 over 2. You divide by 3 over 2, it means you have to times 2 over 3. Plus c. Okay, so more specific, you can write out the final result like this. You got that the power number is 3 over 2. Over 2 is means you have to take the square root. And you got 3 of the sides, 3 power of the side in this one. So after that, you take plus c. And the best method for practicing this equation is integration of the d of the e power to x times with dx equal to ex e power to x plus c. Yes, in the same way with the previous action, I take cos x from outside to inside. Very easy. And integration e power to sine x times with d sine x will have the original function e power to sine x plus c. Just like this. Okay, the last one. Maybe this function is the most difficult for you, but just take the same action with the previous exercise. You will separate cos 3x become to the cos square x times with cos x times with dx. So I will take the cos x inside, taking cos x become to inside the derivative first. B of sine. And maybe you understand. So you remember in the trigonometry function, you will learn very basic method is sine square x plus cos square x become to 1. So cos square x will become to the 1 minus sine square x. This is a very basic of the trigonometry function. So I will rewrite the cos square x is 1 minus sine square x times with d of sine x. And I will separate this integration become to at least two integration, sub-integration. First one is 1 times with d sine x, and minus the second integration, sine square x times with d sine x. We calculate first one. This is a 1 times with dx, so it means it doesn't change this integration. So the result of the first integration is sine x. And this is the power rule integration. Is sine q x divided by 3. And after that, you plus constant number at the end of the operation. It's quite very easy to understand. You just take the focus, take more concentration about the basic method of the trigonometry integration. You got the sine x times with dx become to the d of the minus cos x. You got the cos x times with dx become to the d of the sine x. And after that, you have to take plus c at the ending of the integration. So when you remember the basic method for integration like that, you can do every exercise that's learned by heart the basic method of trigonometry function. Thank you so much for watching this video, and if you like this video, please subscribe or share this video for your friends. Thank you so much.